Hello, everyone. Thanks for tuning in to RGV Community Health Hour. I'm DJ Kalicha Kid. On today's show, we don't have a guest today, unfortunately, and I'll explain a little bit about why after a short music break. So be sure to stay tuned, everyone. Thanks. All right, everyone. Thanks for staying tuned in. Just as a quick reminder, the views expressed on RGV Community Health Hour are for informational purposes only and do not constitute medical advice. Be sure to consult your primary care provider for all your healthcare needs. So, as I mentioned before the music break, I don't have a guest today, and that was kind of by design. I was actually not even intending on doing my show today because there was a Center for Genome Research symposium that was supposed to happen on Thursday that ended up getting moved to spring semester. And so I was selected to do a 15-minute oral presentation, and I didn't find this out until right before the Thanksgiving break. So, you know, I was really busy before the Thanksgiving break trying to get a lot of my work done in the lab to wrap, just so basically, I was doing all my proteomics work. Proteomics is just looking at proteins, and I was doing it in tissue that I collect in the lab, and yeah, so I was just processing 78 samples, which is kind of extraordinary because we only usually do like 10, 10 to 15 at most. And so there's a lot of late nights in the lab. The latest night being 2:30 in the morning here in Brownsville at our the Luis Colom Research Biomedical Research Building. And so, leaving at 2:30 in the morning and living in McAllen and having to do that commute, I wasn't getting home till 3:30 or 4 in the morning. And so there was multiple late nights. 2:30 was just my latest. There was another 1:30, another night where I was there till 1:30, till after midnight most nights. So my sleep schedule got thrown way off because of those late nights and long commutes. And so I had all that work to try to do because I was trying to get it done before the Thanksgiving break, so that way our mass spectrometer that runs the samples, it was going to run. It's going to run whenever I get this all done because it ended up kind of all being for nil. It's going to run for 20 days straight or so, and so I was trying to beat the Thanksgiving holiday so that way, there's basically 4 to 5 days there where it could run while nobody was in the lab, and just kind of get that head start and be freed up that much sooner for other people who need to use it. So unfortunately, I have to redo all those samples because I ended up doing something wrong in terms of, well, I wouldn't say I did anything wrong. I just didn't grab enough starting material. I didn't grab enough protein at the beginning because my assumption was that doing proteomics on tissue, there's a lot of proteins in tissue. And so in the past, I've had so much protein that I end up pulling. I use such a small amount of it for analysis. And so I figured like, hey, I always pull X amount and it's always too much protein. I'm going to pull less and it should be enough protein. Well, it wasn't. And unfortunately, I didn't get enough protein. And so I have to redo all those samples. And so because of that, and because of this 15-minute oral presentation that I was supposed to give this Thursday, I have just been going crazy in terms of preparation and work. And so yeah, I really didn't have too much time to reach. And then, of course, with the Thanksgiving holidays and all that, just kind of was really too busy to send a bunch of emails out trying to loop someone in to be a guest on the show. And I have been in contact with people throughout the semester in terms of them coming on. And, unfortunately, everybody gets so busy around the holiday season, and they start to kind of get into vacation mode a little bit, I guess you could say. Yeah, I wasn't able to reach out and grab anybody for what I believe is the last show of the semester, if I'm remembering correctly, based on what the radio manager had told me. And so, yeah, that's the reason why you have just me today. So, Yeah, it's going to be a good show though, because what I'm planning on doing is, since we're here at the end of the year, and it's kind of hard to believe that it's already not only just the end of the year, but the end of the semester. I feel like I just started the semester, honestly. I feel like I just had Richard Clayton on. He was the first guest of the show, a clinical therapist here at UT RGV that works at the counseling center. I had him on as the first guest of this for the first guest of the show for this semester, and I'll probably have him as the first guest of the show again for next semester, so he can, like for this semester, he wanted to be the first guest so he can talk about all the workshops and things that the counseling center was going to do throughout the semester. And so I think it would be good to have him on again, as the first guest for next semester, so that way again the students can know, like, hey, this is what's going on at the counseling center, and maybe I want to participate in some of these workshops. So I feel like I just had him on, and it's just kind of been a whole whirlwind with all this work that I'm trying to get done, my trip to Boston, this oral presentation that I was prepping for that ended up moving. But overall, I'd have to say that this semester has been quite a success. This is my third semester doing this. I'm very thankful for the opportunity. And yeah, I'd say, I'm calling it a success because I feel like I haven't had as many episodes where I was missing a guest, because it really drives me crazy when I don't have a guest. Um, yeah, I think this is the fourth show this semester that I didn't have a guest, and two of those four were mostly because of scheduling issues with the guests that I ended up having on. Natasha Garcia Rodriguez, she was on a couple weeks ago, and so yeah, because of that, there were some episodes where I didn't have a guest, where I completely intended to have one, but it just kind of fell apart, kind of last minute. And so, yeah, and in the semesters past, I don't know exactly how many guests that, you know, or how many episodes I did that I didn't have a guest, but I came into this semester really intent on having a guest for every show. So overall, I didn't accomplish that goal, but overall, I feel like I did really good. I had a wide variety of guests from, like I mentioned, Richard Clayton. I had on Joshua Moroles to talk about, all kinds of different things in terms of water quality and environmental aspects of living in the RGV. I had on undergrad, which was the first for our show. Our last guest was an undergrad who volunteers in our lab. I had on multiple graduate students from our PhD program. I had on Aaron Manusov, recently retired Dr. Aaron Manusov, which I've been trying to get him on for over a year. Oh, I guess about a year. It was last semester when I tried to get him on. But so yeah, overall, I have to say I gave it my best, and fell short a few times here and there. But hey, that's part of the human experience. So. But my commitment over this winter break is to really, reach out to as many people as I can and get as many lined up as I can and ready to go for next semester, with the assumption that I will be brought back and being able to do the show again in the spring. So with that said, I just wanted to give you a little bit of a backdrop on why we don't have a guest today, because like I mentioned, I honestly wasn't really intending on doing the show. But with everything kind of getting shifted around in terms of that symposium that was supposed to take place on Thursday, I figured, like, hey, why not hop on, play some music, and talk to you all a little bit about some incredible scientific advancements/discoveries that happened this year. So what I'm going to talk about may not always completely apply to the RGV, and that's why I try to keep this show really focused on RGV health. But hey, last show of the semester and last show of the year, so let's break outside that box a little bit, everyone. So when we get back from this next music break, I'm going to give y'all a rundown of some really cool science findings from this year. So stay tuned, everyone. Thanks. All right, everyone, and we're back. So before the music break, I had mentioned talking a little bit about scientific discoveries that happened this year that are really mind blowing. And the first one I want to talk about, really, I also mentioned before the break that they might not all relate to the RGV. And I try to keep everything we talk about on this show as RGV focused as I can. But as I talked about with my guest a couple weeks ago, Natasha, she's doing research on microplastics and phthalates in the plastic and how that impacts human health. And so I highly recommend. I think that's one of the episodes where we had some difficulties and the audio wasn't coming through for that episode. So you'll have to catch that episode on YouTube when they upload it. But I highly recommend going and listening in because it was really interesting talking to her about microplastic research and what's known and ways you can kind of mitigate your exposures to those types of things. But the first thing I want to talk about is the microplastics again. And in this year, microplastics were found in human testes and brains. So it's really a discovery that's both fascinating and concerning. Researchers have recently found microplastics in human reproductive tissue, including testicular tissue and even inside the human brain. These plastics are tiny, sometimes smaller than a grain of sand, and they come from everyday life: water bottles, food packaging, clothing fibers, even dust in the air. And that was one thing we talked about during our show was, if you can mitigate it, buy a stainless steel water bottle to refill your water, use reverse osmosis if you can. Try not to microwave any plastic like Tupperware or what do you call them? Paper plates that have the coated paper plates that have like a fine layer of plastic on them. But what was really fascinating to me is just the dust in the air carries microplastics. It carries a bunch of other terrible stuff too. But during the episode when Natasha and I were talking about ways to mitigate our exposures, those are things we mentioned. Don't microwave plastics. Try not to drink from, plastic water bottles. Buy a Stanley or one of these, stainless steel Arctics or Yeti cups or whatever. And I mentioned to her that I was watching, in preparation for the episode with her, I was watching some stuff on YouTube about microplastics and exposure, and Peter Attia, who is, kind of a famous aging scientist or researcher, he talked about in his home, he actually upgraded his HVAC system, like, because he's like, hey, I work from home. I'm usually at home more times than not. And so he found it worthwhile to drop a lot of money to upgrade his home HVAC system to essentially be on the level of a medical facility that can handle a higher rated MERV. I want to say that's what it's like the MERV ratings. I don't know what it stands for, but yeah, those higher MERV rating filters. A lot of residential homes can't handle the higher level filters because they're not intended to be I guess as sanitary as a hospital or clinic kind of setting. But he, spent the money and upgraded his home HVAC system to handle those filters. And so that's why I find it kind of insane that even the dust in the air carries microplastics and all kinds of other things. So yeah, on one hand, this discovery is alarming, but on the other hand, now that we know it's happening, science can begin to study the effects and look for solutions. So, the question then becomes, what does long-term exposure do to development, fertility, and neurological health? And there's probably really great research that's going to come out over the next couple of years using animal models and other, stem cell models, animal models to investigate that. But more importantly, how do we reduce that exposure as a community? Like I had mentioned before, there are various ways. Not only people, but also local city ordinances and state governments are trying to kind of mitigate our plastic exposure and single-use plastics. I had mentioned in that show with Natasha that when I went to Boston in October for a conference, I went to Target and there was nothing but reusable bags in the aisles rather than the single-use plastic bags. And I've lived most of my adult life in Washington State, and Washington State, when I moved out of there, away from there for this PhD program, that was one thing they were trying to transition to, is getting rid of all the single-use plastic bags and, having reusable bags as options there. But really, what um, surprised me the most about it was, obviously you're being charged for these reusable bags, and then I thought it was going to be, at least 25 cents per bag that I was going to get charged, but it was actually just 5 cents per bag, which really isn't too bad in terms of getting a reusable bag, and really keeping a lot of that terrible stuff in the environment. It's always so heartbreaking to see, and I kind of joked with Natasha about it. Not that it is a joke, because it really does happen, but these plastic bags end up in the ocean, and then they look like jellyfish to some sea creatures like sea turtles, and they end up getting eaten because the turtle thinks it's a jellyfish, which it's absolutely not. So 5 cents is a small price to pay for taking care of our environment. So moving on, CRISPR, we get to, I'm fortunate enough to use CRISPR in our lab to do our experiments, and it's really such a remarkable tool, and we're really just at the tip of the iceberg in terms of genetic engineering with it. But CRISPR gene editing is now treating human disease. So we are officially living in the era of DNA medicine. And if you don't know about CRISPR, which, talking to people, quite a few people don't know about CRISPR, which blows me away a little bit, especially with the dire wolves that were, announced and coming back from extinction, and also the woolly mice. Those are both really remarkable things that came out this year. And I feel like, not to say that people should know CRISPR in terms of its like, on a scientific level, but they should, people should at least know, like, hey, CRISPR, regardless of what you know about it, is the reason why we have dire wolves now. But yeah, so CRISPR, just for a little bit of a background, it's essentially a way for us to cut and paste DNA in a very, very simple fashion. So the same way you would cut and paste in a Word document, it's the same thing, but our DNA is essentially a Word document of A, C, T's, and G's that are 3 billion base pairs long. And so now we can go in and find, and then our genes in all those base pairs are, certain regions of that code that, or certain regions of that DNA that code for proteins and other things as well, but, for proteins really. But yeah, so this gene editing tool was really just used in research labs for the most part, but now over this year, it's been used in human patients to treat genetic blood disorders like sickle cell disease. For decades, we treated symptoms. Now we're beginning to fix the actual DNA code that causes disease. There's even a next generation version called prime editing, sometimes described as a word processor for DNA, because it can edit genetic code with incredible precision. Now, of course, with great power comes great responsibility. And, ethically, should we use this to treat cancer or prevent hereditary blindness? Should we allow edited embryos, designer babies? Where is the line? Medicine is changing, and we're alive to watch the shift happen, and it really is incredible. I know there was a 60 Minutes episode this past Sunday about a team of high school students that are using CRISPR to develop a test in order to, diagnose, is diagnose the right word? To identify or diagnose somebody with Lyme 2 days after they get infected with it, versus I think the current method, I didn't watch the episode, I've just seen the small clips here and there about these students that were doing this research as part of a worldwide competition. But yeah, so from what I remember them saying, if you get if you get bit by a tick with Lyme, it usually takes a couple of weeks, probably, a couple of weeks after symptoms start to show, and you feel terrible enough to go to a doctor, that they're able to actually identify it. But now these students are developing a way to identify somebody, having Lyme just days after being infected. So, I mean, and like I said, that's just the tip of the iceberg. There's just so many remarkable things that are going to come out of this, and also probably some pretty horrific things, because once the genie is out of the bottle, there's only so much control people have over it, and it's no different than nuclear weapons. So, of course, nuclear technology was developed to essentially win World War II, and that was kind of the dark side of the technology, but the bright side of the technology is being able to create nuclear power plants and clean energy and power our nuclear submarines that can, stay underwater for years at a time. And of course, also power our scientific probes that we send all over our solar system and, outside of the solar system. But I guess, really it's just Voyager that's gone out there. But, and I doubt I'm not sure how they powered Voyager exactly. But yeah, anyway, it's just so remarkable to me that CRISPR has so much potential to change so much. But on the other side of that coin, it also has the potential to be used in a nefarious way, right? Creating super soldiers and armies of just, it's almost like Metal Gear Solid, right? Like you have genome soldiers in Metal Gear. So it's essentially where we're at today. Moving on, I'll kind of go over one more thing before taking another music break. So artificial intelligence solved protein folding. For decades, one of the biggest unsolved challenges in biology was predicting how proteins fold. And if you are a PlayStation, I wouldn't say fanboy, but if you've had PlayStation over the years, the PlayStation 3 actually was powerful enough to where a research university developed a program called Folding at Home, and you could use your PlayStation 3 just by leaving it on to run simulations of protein folding, and the program was called Folding at Home. It was on the PlayStation 3. And so for years, scientists have been trying to use crowdsourced methods like that. Like, if a bunch of PS3 users around the world all left their PlayStations on for this Folding at Home program, it essentially becomes like a supercomputer. And now we have AI that can help us. And actually, the Nobel Prize was awarded this year to DeepMind researchers, which is Google's kind of artificial intelligence research team. So proteins are tiny molecular machines that keep us alive, and their shape determines their function. Misfolded proteins are linked to cancer, diabetes, and Alzheimer's. DeepMind's system called AlphaFold predicted the structures of over 200 million proteins, almost every protein known to science. This discovery could accelerate drug development, vaccine research, and personalized medicine at a pace we've never seen before. And not only is it able to kind of predict the way proteins are folding in terms of proteins that we are aware of and that we know about, it also has the ability to basically create synthetic proteins and develop new types of proteins to do work that we never thought possible before. And so, like I said, this is really going to revolutionize our world. CRISPR and, of course, AI and this protein folding, right? Because like I mentioned before when I was talking about CRISPR, essentially our genes code for proteins and the proteins do the work. And now we have AI to help figure out how they fold and and then how to put them to work in terms of that. And so, we even have proteins, enzymes in our laundry detergent that help break down, like organic, like grass stains and things like that. So we're a lot more interweaved with proteins than most people even realize. So I think it's really remarkable that they're going to essentially be able to create customizable proteins to do certain work. And so it's going to be really interesting to see where everything comes around in the next couple of years. So with that, everyone, I'm going to take a quick music break, and we'll be right back to talk some more about some incredible science findings from this year. So stay tuned. Thanks. All right, everyone. Thanks for staying tuned in. So, to continue on our journey of amazing scientific discoveries that happened this year, for me, I'm a huge space nerd. I love everything about outer space and our galaxy and the universe and learning all about it. I'm a religious watcher of PBS Space Time on YouTube. And if you're into anything space, I highly recommend that channel. If you don't know about it, Space Time. It's such a good YouTube channel. And so, with that, the James Webb Space Telescope found possible signs of life chemistry. And the James Webb Space Telescope, I'll never forget watching it launch and just holding my breath because it's such a remarkable instrument that has already, it's only been up for what, maybe a year, maybe two, and it's already changed what we know about our universe. So the James Webb Space Telescope has detected chemicals in the atmospheres of distant planets that are normally associated with biology. One molecule in particular, dimethyl sulfide or DMS, on Earth is only produced by living organisms, mostly plankton. Now, it's still early and needs confirmation, but if verified, this would be one of humanity's most significant discoveries, evidence that we may not be alone. And even in this space, if this special case doesn't hold up, Webb has already shown us galaxies, black holes, and star systems forming only a few 100 million years after the Big Bang. It's rewriting astronomy textbooks in real time. And so, like I mentioned, it's just so remarkable that this instrument, it's kind of, it's like, if you're a huge space nerd, you probably know about the Hubble what is it called? I just had it. The Deep Field Image, I think it's what it's called. So basically, when the Hubble Space Telescope went up, which sees in the visible wavelengths of light, they pointed it at what they thought was an empty part of space, right? Just completely black, couldn't see anything. And then they took the photo, and in the photo, a bunch of galaxies popped up. And that's when they realized, like, holy crap, we thought we were just pointing this thing to an empty part of space, which obviously wasn't empty, right? If you have a strong enough magnification, it's almost like a microscope, right? You can grab a sample of pond water to your eye. You might not see anything but water, but you put it under a microscope and you're going to see all kinds of microbes and organisms in that water. So in that same sense, the Hubble Space Telescope looked at an empty, quote unquote, empty part of space and saw a bunch of different things. And now, with the James Webb Space Telescope, it sees in the infrared, and so it sees things that we can't see with our eye, with our naked eye. And so, yeah, so it's really finding all kinds of amazing things that, that we could have never even thought possible. So, man, it's just so cool. I love learning about space, and, if I had to guess, further down the line, maybe 10, 15 years from now, I might just go back to school and try to pursue a degree in cosmology or astrophysics or something, because I'm just so fascinated with space. And of course, I love all types of all different types of science, but biology is really fascinating to me, and so is space science. And so, moving on, scientists grew Neanderthal-like mini brains. Scientists used ancient DNA from Neanderthals and created what are called brain organoids, tiny lab-grown clusters of brain cells to compare to human ones. And it's another thing that we do. If you're a regular listener to our show, I've mentioned that in the past in terms of in our human genetics department, we have a stem cell lab that creates organoids. Most of our stuff is in Brownsville, but that's one of our few things that we have in the Edinburgh area. And so, yeah, these organoids are really remarkable things. And so these Neanderthal model brain cells behaved differently. They formed networks more slowly. They produced different patterns of electrical activity, and they created different brain-specific proteins. This may help explain why humans developed language, art, and technology, and Neanderthals did not. So this begs the question, what makes a mind unique, and what makes us human? Actually, I was just another great podcast I watch on YouTube. It's called Star Talk. It's hosted by Neil deGrasse Tyson. Um, I'm sure most people have heard that name if they're not familiar with who he is. And so I just learned on my trip over here today that our brains actually were more, how did they word it? They basically were saying like our brains were developed in terms of music and sound, like, like conveying messages with, obviously, right before we had language, we were basically just grunting at each other. And so music was kind of one of the first things our brain was kind of being wired to understand, and I guess kind of interpret, I guess is one way to put it, with language coming later. And so I thought that was really remarkable. Moving on, progress toward room temperature superconductors. Researchers are getting close to creating a room temperature semiconductor, a material that can conduct electricity with zero energy loss, no cooling required. If perfected, this would revolutionize power grids, transportation, magnetic levitation systems, quantum computers, efficient renewable energy storage. Some attempts have been controversial or unverified, but the race is on and breakthroughs are getting closer. Humanity may soon enter an era where electricity flows freely, efficiently, and cleanly. Um, and back to the plastic topic, one thing that was discovered this year is a fungus that eats plastic. So scientists discovered fungi in the Amazon rainforest that can break down plastic rapidly, even without light. If scaled safely, this could transform recycling and waste management, helping us address one of the largest pollution problems on the planet. Nature often holds solutions long before humans figure them out. And that actually kind of reminds me of something I saw many years ago. Humans thought that we invented the screw, right? Like your normal screw, right? Instead of using nails to put something together, you can use screws. And so they didn't see any, other than the shape, right? There's a lot of different um, organisms that have kind of like a screw shape to them, essentially, right? Like there's obviously small microbes that are spiral and things like that. But scientists, I want to say it was the weevil, which is like a small beetle, I think. That's actually how their legs work. They're basically like screws that move, and so it was really remarkable to see um, that kind of mechanism in a living creature. I'd have to look more into that because it's been so long since I've remember hearing about it. But I thought that was really fascinating that there's an insect out there that has screws for limbs, essentially. And so we'll be right back to end the show. But for now, we're going to take one more quick music break and come in and wrap it up for the fall semester. So stay tuned, everyone. Thanks. All right, everyone, and we're back. I know that there probably aren't, a large percentage of the population probably don't listen to this show, and obviously there's so many, UTRGV students that don't even realize that we have a radio station. When I talk to them a lot of times about my show or about our show, I hate to call it my show because I started this to have people on and share information about our community. So while I am the creator and the host, I hate to call it my show because, yeah, it seems a little bit narcissistic, I guess you could say. But one thing I do want to share that I just saw online is that there is a water boil notice for Harlingen, people in the Harlingen area. A precautionary water boil notice has been issued. So, um, if you are listening to this right now and you have loved ones in the Harlingen area, be sure to share that news with them, especially the elderly whom may not be so, tuned into social media or, the news. So, we're here to keep each other healthy and safe. So be sure to share that information. And so finally, my closing message, what do we take away from all this? We are truly living in one of the most extraordinary periods in human history. And, it seems like every year we're taking such leaps and bounds in advancements in our technology and our understanding of the entire universe and the world around us. It's really so incredible. We truly are the luckiest generations alive today. There's, obviously in the past there was a lot more sickness and disease, not so many treatments and cures, and now there's just so many clinical trials that are going on to develop next generation medications for people who are sick. On top of all the other remarkable things that are happening, AI, quantum computers, everything we're learning about outer space with all our incredible technologies and scientific instruments. Um, the gravitational wave observatories. There's just so much really cool stuff out there. And there's so many different ways to contribute. A lot of times people don't, someone with a accounting degree may love like space science, but they don't ever feel necessarily like they can contribute to that goal, which is absolutely not true, right? So regardless of what field, or I guess, yeah, whatever, no matter the field a company or organization is in, they always need accountants and lawyers and administrators and XYZ, the run of the mill secretaries and all that stuff. So you can always put yourself in a great position in terms of job satisfaction, right? You don't have to, let's say you get a degree in accounting and you want to get a good job. Well, you could work for Amazon making decent money and, maybe going through a little bit of hell due to the, kind of the culture of working in a mega corporation like that. Or you could also work for NASA, so it's like, there's always different career paths no matter what your field of study is. And so I always tell people, don't shut the door on your own face, right? You should always apply for that job, even if you don't think you're going to get it, right? Like, why are you going to, like I said, shut the door on your own face? So, take the leap, send that cold email, inquire about a position, and you never know where things are going to end up. Another great YouTube channel I watch kind of regularly is Veritasium, and it's another science YouTube channel. And the most recent episode, one of the producers at the end talked about his experience, and he was reading a book, and I don't remember the exact quote, but essentially it said something like, one decision can change the course of your entire life. And so you got to step outside of that comfort zone and just go for it, because what do you have to lose, right? Like, it's one of those things where if you don't get that job or that recognition, I wouldn't even call it recognition, but if you don't get what you're seeking, you're already starting where, you're already at where you left off before you inquired about that stuff. So there's only potential to move on and to grow, not only as a, personally, but also professionally as well. So with that, we're living in a time where we can edit DNA, grow brain cells in a lab, and not only brain cells, all kinds of different cells and organoids, the ability to detect possible life on distant planets, and rethink the very laws of energy and matter. Our job as a community is to stay curious, stay informed, and stay engaged, because the future isn't happening somewhere else. It's happening right here, right now, during our lifetime. So with that said, everyone, I just want to thank you all for listening to the RGV Community Health Hour. It's been such an amazing semester. It's gone by way too fast. I can't believe we're already reaching the end of it. And if you enjoyed today's show, share it with someone who loves science, curiosity, and big ideas. And like always, stay curious, stay healthy, and let's thrive together, RGV. Until next semester, everyone have a good Christmas break, and I hope y'all had a great Thanksgiving break. So until next time, everyone, take care. I love you all, and peace.